Okay, so reflection over the y equals -1. So reflections in general, so that page I sent you to, it depends on what you're doing, but you're basically just switching across. I'm a visual person, so the rules don't always help me. Reflections, I like to do like visually, actually graph them and look at them. But there are rules if it is across the x-axis, the y-axis, the y equals x, or the y equals -x. If it's across a specific line, that's not necessarily going to always be the case because it's not on that definitive line. It's somewhere else. But so these are just a bunch of like short rules that may help you generalize what's going on in case of having to always graph it. If you're more like algebraic and rule fan. So in this case, if you're going to reflect over or across the y equals -1, what I always do is like, this is my y equals -1. And so relative to it, I look for each point. So in this case, B is 1 to the right, so I'm going to go 1 to the left. And that's going to be B prime or B apostrophe. That's the new one. So D is 2 from my line to the left, so I'm going to go 2 from my line to the right. And then C is 1, so 1 to the other side is going to be C. And again, the one thing I did realize last semester a lot with a lot of people is paying attention from your original to your new figure and the notation, those markings. Even I get kind of mixed up in them because I get excited. And it is not consistent in the formatting, depending on the worksheet, the teacher, the website, which one is going to be like red or the brighter color. Sometimes it's the starting figure versus the one that's finished with your transformation. So like number 2, it says across the x equals -2. Oh, and I definitely did that completely wrong. I definitely did x -1, not y. So this is not correct. That would be x -1. I was looking at the other one. Mixed them up. Sorry. Get rid of that. Start over. So y equals -1 is that horizontal line. So that's where I messed up. So we're actually going to reflect it over y equals -1, not x equals -1, which is what I did. But still the same conversation as far as the rest of that stuff. So still from this line, so this is going to be D prime. C is 1, 2, 3, 4 above it. 1, 2, 3, 4. So that's going to be C. B is 1, so it's going to be 1. And so that would be the reflection over the y equals -1. Again, the previous one that I just erased is x equals -1. So number 2 is x equals -2. So -2, this is where x is. This is going to be our line where we reflect it or use as our home base, maybe is kind of how I like to think about it too. So that means h is going to come over here where f is. So that's going to be our h prime. F is going to come over here because it's 1 to the right, so now it's 1 to the left, and vice versa for h. G is going to be 1 over. And then we will have reflected across the x equals -2. So it is important to remember x, like Hoivuk. So horizontal line is a y equals, vertical line is an x equals. So reflection number 3 is x equals -1. So if I go over here to where x is -1, this is my line. So that means s is going to be 1. So that's s right here. R is 2 from our line. So that's R. Q is 3. And T is 1, 2, 3, 4 from the line that we're reflecting across. So I'm going to go 1, 2, 3, 4 the other way. And that's our new figure there. So reflection across the y-axis, then your x just becomes opposite of what it was because it's going over to the different quadrant. So when it reflects over the y, your xy becomes -xy. So opposite of whatever it was, just in case you're looking at coordinates. So in this case, like this is -2, 0, it's going to become +2, 0 because it's reflecting along the y-axis here. So it mirrors over that line. So where G is -1, -5, it becomes +1, -5, down here. Then our D, it looks like is a -5, -4, so it's going to become a +5, -4. And E is -5, -2, so it's going to become +5, -2. And like I said, that rule really only works for the y-axis, the x-axis, the y equals x, and the x equals y. Oh, I'm sorry, y equals -x. And that's just being that perfect diagonal line with the one-to-one slope here, and then the negative is the one on the other side. So for the x-axis, your y values just become opposite. So xy becomes x -y. So if we're going to flip it above, or mirror it, I should say, not flip, mirror it above our x-axis, that means u is going to stay right there. V is going to go one above because it's one below. Then we have W, which is 1, 2, 3, 4. So 1, 2, 3, 4. T is 4 down, so we go 4 up is T. And then we have our new reflected shape over the x-axis. Over the x-axis. So again, when it's x equals -2, so that's a vertical line, Vux. So that means -2 is here. This is the line where it's all going to be referenced from. So D is 1 to the right, so it's now going to be 1 to the left. C is 3 to the left, so now it's going to be 3 to the right. E is 2 to the left. It's now going to be 2 to the right. And then we have reflected over the x equals -2 as well. As far as your coordinates, so your original one was a -1, 4. And the new D, like as far as this is D, and then D new one is -3, 4. So it probably, I guess the other way, algebraically, you're figuring out how far is it from that -2. And then going the other side of it if you had to do it without graphing. I can't think of a reason why you couldn't graph it, but it's all relative to that -2. So even thinking about just your number line where -1 falls, so 0, -1, -2, -3. So all based off of here, -1 is 1 to the right, so it'd be -3, just 1 to the left. And then if you were to do E, which would be negative, the original one is -2, 0. The new one is 0, 0. So reflecting over, and that is not right, it is -4. Perfect. -4. So it's 2 to the left, so I would go 2 to the right on my number line to get my new x value, 0, because it's reflecting across the x-axis, if you're looking for algebraic understanding rather than just visual graphing. All right, so in this case, like if they give you a point, then of course you have to graph it yourself. So your first one is -4, -1, -3, +3, -1, 0. So this is J, I, H. And we're reflecting across the x equals -3, which is here. So I will stay the same. And J is going to go 2 to the left since it was 2 to the right. And then H is going to go 1 to the right because it was 1 to the left relative to our reflection line. And then it reflected over. I like to think of it as if the original shape was wet ink and we folded on whatever line they say to like tell us to fold it on. Y equals -x. That's that line that goes this way. And that one does have a rule as well. The y equals -x is they flip. So xy becomes yx. And because it's the negative one, they both flip signs as well. So not only do they flip, but they flip completely quadrant. So your y's become negative and your x's become negative. So if we look at our first one, so I being -4, 0, with our transition, it's going to be +4, -0, which 0 is not really that important. J is negative 5, 3. As it flips, it's going to become, oh, and that's not even right. I didn't do that right the first one. Again, I'm talking too fast, moving too fast. Close, but no dice. So y comes to the front, so it becomes negative 0. X goes to the back, and it becomes positive 4 because it's the opposite. So we're going to flip them, 3 and 5, and then they become opposite signs. So it's a negative, and then 5 is going to become a positive because it was negative. K is negative 3, 4. So we're going to flip it. The negative 3 becomes a positive. Then positive 4 becomes a negative. And then L. So flip and make them opposite, which again, negative 0 is the same thing as 0. And this is what it would look like also visually. So if I went to negative 4, 0, that's I. J is negative 5, 3. K is negative 3, 4. And L is 0, positive 3. So for our first initial shape, then to reflect over, so this is going to be here because it's 1, if you see it like 1 away from. But also K, we went from negative 3, 4 to negative 4, 3. So negative 1, 2, 3, 4, 1, 2, 3. So our new I value is 0, 4. And that's because if you count these diagonals, 1, 2, 1, 2. So that's why I is here, or your rule. J is going to be up negative 3, 5. And that's again because of that 1 to 1 as well. That's K, I, apostrophe. And then L is going to be negative 3, 0. And then if you put this shape together, so you can do it either way, depending on which kind of makes more sense in your brain. Now, rotations, in my opinion, I would 100% memorize the rules. And clockwise and counterclockwise matters. So 90% or 90 degrees clockwise is the same thing as, 90 degrees clockwise, so that's going to the right, means our x and our y is going to become y negative x. So 90 degrees clockwise, they flip and x changes its position. So in this case, I just have s down here to start with, and that s is 1, 2, 3, 4, so it's 0, 4. So to move it 90 clockwise from where it is, that means I'm moving this way 90 degrees. If I switch them, it's going to be 4, negative 0. Whoops, clockwise. That's not right. Clock moves this way, right? Clockwise. What did I do wrong? 0, y, x. 90 degrees clockwise. 90 degrees counterclockwise. Should be right here. Isn't that the way the clock works? Clockwise. Yep. Counterclockwise. I'm looking at the cheat sheet, making sure the cheat sheet's right. About the origin, which is about here. Your new S should be here if we're going clockwise, because this is the way a clock runs. Oh, negative 4. That's why. So it's negative 4, 0. Our rule was right. So negative 4, 0. S is 2, negative 5. 90 degrees clockwise again, so that's x, y, whatever it is, turns into y, negative x. So we're going to flip negative 5, negative 2. So again, you're moving 90 this way, so negative 5, negative 2. Oops, negative 5. Negative 5, negative 2. I'm going to get it right eventually. So it moves each quadrant. Also is another way to think about it as far as your 90 degrees as it's turning. So it went 90 degrees clockwise because that's the way a clock runs. About the origin. They gave us all the same ones. Let's pretend like this is counter. So -1, +3 is P. Counterclockwise is the other way, so this way. And counterclockwise, you're going to flip them and make the y negative. So xy becomes yx, and y is opposite. So our P is a -1, 3. And we want to rotate it counterclockwise, which is turning to the left. And we're going to flip those. So it's going to become 3, -1, but we make our first one negative as well because y becomes negative. So -3, -1. So -1, 5. 180 clockwise or counterclockwise is the exact same thing. So xy just becomes -x, -y. So they don't switch spots, they just become opposite symbols. So since y is -1, 5, -1, 5, 180 degrees, whichever way you want to think about it, is going to become a +1, -5. +1, -5. And that's a 180 this way. It's also 180 this way. Also a good call out as far as your 90 degrees clockwise and counterclockwise, you will also run into 270 because a full circle is 360. So 270 clockwise is the same thing as 90 counterclockwise. So 270 clockwise is the same rule as 90 counterclockwise. 270 counterclockwise is the same thing as 90 clockwise because it comes around and hits the same place. So like if you're looking at 3 o'clock, if I go 90 counterclockwise, I would hit 12 o'clock. If I go 270 clockwise, so from 3 o'clock I go down to 6, that's 90. Yep, and then to 9 is 180, and then up to 12 o'clock is 270. So that's why they work interchangeably. They'll just ask the question with different numbers. To write a rule to describe the transformation. So in this case, you're looking at what happened to G. It looks like they definitely flipped, but the y value switched. So they flipped and the y value switched. So these are going to be rotation 90 counterclockwise because that's where you have your xy becomes yx. And your y value switches. So 90 counterclockwise. This one, again, the value switched. It's definitely going to be rotation again. So it became xy, became yx, and y became opposite again. So that's going to be 90 counterclockwise as well. Oh man, they all did it. Exact same thing. Sorry. So they flipped, it looks like. Oh no, and the x became negative this way. So this is xy. It became yx, and then we made it opposite. So that's a rotation 90 degrees clockwise because only your x changes then. This one, they just became opposite of each other. So that's your xy. This is still x and y, but they're opposite of what they were before. And that's a rotation of 180 degrees, clockwise or counterclockwise. Completely up to you. Translations, I think, are super easy personally, graphically or algebraically, because you're just looking at the change from x to the next x. So if I look at E, my coordinate is 2, -1, and I'm just going to plug that in. So 2 minus 6 is going to give me a -4. Y plus 1 is going to give me 0. The other idea is this is going to move left 6 and up 1. So I'm going to move my E 1, 2, 3, 4, 5, 6 and up 1. And that's where the -4, 0 comes from. So D is 4, -4. We're going to subtract 6, which is going to give me a -2, and add 1, which will give me -3. Or take D, move it to the left 6, 1, 2, 3, 4, 5, 6, and then up 1. So that's our D. Translations are just slides. And then F is 1, -4. It's going to become -6. It's going to be -5. Plus 1 is -3. So 1, 2, 3, 4, 5. Whoops, I'm doing E. D, we're going to -5. So 1, 2, 3, 4, 5. F, I'm going to get this right one day. And then to -3, so it's up 1. So it moved to the left 6, 1, 2, 3, 4, 5, 6, and up 1. To the left 6 and up 1. Another way to recognize translations versus rotations or reflections, especially if they give you both shapes, is that they're in the same orientation. So F and D are still on the bottom, F and D are still on the bottom, and E is at the top. So it's just sliding. There's no turns if it is just strictly a translation. So in this case, X went up 2. So that means I know I'm going to go up 2, and then Y went to the right 3, 1, 2, 3. So that's U. V went up 2 to the right 3. That's V. T went up 2 and to the right 3. So that's our new T. All right, so we're about to max out our time. Do you have any questions, or did that help some, hopefully?